Sharon ma'am, can we start right now?
Yes, ma'am.
Okay. Good morning, one and all. I, Dr. Neeru Malik, welcome Dr. Pallavi Ahire ma'am, today's speaker. So I would like to give her a brief introduction that Dr. Pallavi Ahire madam received her PhD degree in Computer and Information Technology from Department of Technology, Savitribai Phule, Pune University, India. She has been awarded with the 3 Best Research Paper Awards also till now at different international conferences. She has published 21 research papers in reputed international journals and conferences. In fact, she has 17 books in her name also. She is also a principal investigator for a research project and fetched a research grant of rupees 2 lakhs from Aspire SPPU Pune. She had a total 19 years of teaching experience and also received the Best Teachers Award. Now I hand over the stage to today's speaker, Dr. Pallavi Ahire madam. You can continue.
Thank you, Dr. Neeru. Sharon, am I audible?
Yes, ma'am. Yes.
Yeah. Shall we start
Yes.
then?
Yes.
Yes.
Yeah. Okay. Thank you. Please let me know once my screen is also shared.
Yes, ma'am.
Yeah. Okay. Thank you, Sharon. So we are good to go now. Shall I start? Sharon?
Yes, ma'am.
Yeah. I can go ahead. No, I can start.
Yes, ma'am.
Yeah. Okay. Thank you so much, Sharon, Dr. Neeru, and Pimpri Chinchwad University. I, Dr. Pallavi Ahire, and I'm working as assistant professor at Pimpri Chinchwad University. And I'll be delivering a topic for today on art of securing software. My email ID is pallavi.ahire@pcu.edu.in. So after webinar, if you do have any questions, you all are welcome to contact me. The outline of my presentation would be, I'll be giving you introduction, all the security statistics, software protection techniques, what all software protection mechanisms through code obfuscation. How can we classify those mechanisms? I also have evaluation of obfuscators lively. I will show you that also. And I have my own mechanisms which are developed and designed. So those software mechanisms also will be discussing along with the experimental evaluation. And finally, I will conclude my talk. So as we all know that in today's era, data privacy is all really matters. And when it comes to data privacy, it is not only on information, but the data is not only on information, but sometimes it's on software or a software programs too, or a piece of source codes as well. At the same time, since we are actually going through a gigantic infrastructure which is provided by the cloud, nowadays we all are heavily dependent on a cloud. We are relying on a cloud for not only storing our data, but cloud manages to compute it and manages the complete data for us. So irrespective of our liability with the cloud, our dependency of the cloud, as we all also know that cloud is not that secure enough to store our information, because cloud also has its insider attackers who can steal our information. Now, when it comes to software is always having intellectual property. And that intellectual property is in the form of its algorithms, is in the form of its logic. So protecting that software is one of the very important security concern nowadays. And for that, the mechanism which is being used is the source code obfuscation, which is the objective of my today's talk. Now, if we just go through the cybersecurity statistics, you would have observed the graph which I have plotted here. And daily, there is a loss in the data, which you could see as and when we are progressing. And we are also spending a lot many US dollars in order to secure that data. Almost half of the companies, they have over 1,000 sensitive pieces of information, which is not yet protected. And companies are actually providing more than $6 trillion annually by 2021, and which is the cost the cybercrime is actually paying to protect the data. But still, we could see that almost 400% of attacks are still expected in the healthcare domain or in the other domains as well, in the productivity domain. So biggest cost and the biggest concern is actually on to protect that data or to protect the software. So there are variety of software protection techniques. Let me also tell you that I'm actually not talking about what are the data protection mechanisms. Data protection mechanisms are very well known. Apart from that, there is a wide era which actually comes out to be a software protection mechanisms. And there are mainly software protection mechanisms in the form of code obfuscation. Code obfuscation and detail I'll be talking. Second one is code watermarking. In that case, actually, how can we go for a privacy attacks, piracy attacks, and that we can have a watermark. We can add that into a software, and we can prove that this software belongs to us. The same way we used to do for our documents also. So code also has watermarking mechanism. Secondly is the tamper proofing attack. So in order to get rid of those tamper proofing attacks, we also can use the parity bits in order to protect our software. Now moving towards on top of it, we have a code obfuscation mechanisms. These mechanisms will protect our software against all the reverse engineering attacks. Now what is those attacks? When the software is lying in the cloud and when the software is in the execution. So there are basically two ways of protecting it. So malicious reverse engineering attacks talks on when the software is in execution. So when the software goes and stores into the cloud, it is always important to protect that particular software. So software protection comes out to be birthmarking mechanism as well and watermarking mechanism as well, which allows programs to be tracked. But a birthmarking mechanism can detect the code, which can lift the program to other and to identify how many copies are being developed. Apart from that, we have a code-oriented obfuscation, which could be done, as I said, done at static time and at dynamic time, like at compile time also, and when the software is in execution, that is runtime also. So as I said that there are mechanisms which are available like encryption. You might have heard about the word encryption because it is widely used when it comes to data. So I have given one example here that if I have a string that hello, how do I encrypt that? I can apply any of the available algorithms like RSA algorithm, SHA algorithm, MD5 algorithm, and I can convert this into something like this. So we have to use a method of cryptography wherein encryption would be a process for encoding my message in such a way that unless and until it is not decoded at the receiver side, then the attacker in between will not be able to understand that whatever I have written. Now, even though this mechanism is widely used for the data, but we cannot use this mechanism when it comes to software. Because in the software, when we write the code as integer a comma b, it would be converted to encrypting mechanism of something like this. Then my compiler is not able to detect that. So that's what the real objective is or a gap is. Apart from that, there is a mechanism of a tokenization wherein we can go for adding the tokens in the form of payments, and these tokens would be adding all the sensitive data with all unique identification symbol, and they try to retain your essential information and without compromising on its security. So in this case, we can take example of our payment card industry, and which allows all the credit card numbers to be stored on one particular machine, and then we can use it into the databases after the transactions. So this is the another mechanism like tokenization I said, or encryption I said. But as I already told, and I will explain also that these mechanisms we cannot apply when it comes to software, because software, if we try to execute or encrypt it like this way, then it won't be compiled, it won't be executed by the particular compiler. Then it has no meaning, because softwares are always written for some objective, and when we write a code of addition of two numbers, it should produce the result as addition of two numbers. Then how do we protect our software? So what is the art in that? So art of protecting software, which comes with source code obfuscation. So obfuscation is one of the widely used era in which there is a process that we can camouflage the source code. And it's up to us that whether we are going to make it partially or wholly in order to make the original outcome exactly as it is, so that it would be very difficult for the attacker to trace that what logic we have written in the source code. So you may be thinking of currently that when it comes to addition of two numbers, we accept two variables from the user, we write C is equal to A plus B. So how can I camouflage that? How can I change that? That still the output should be addition of two numbers, but by looking into the code, my attacker is not able to understand that what the code is written. So source code obfuscation is actually dependent on these two cases, that if my original program failed to terminate, if it has any error condition, my obfuscated program may or may not have any error conditions, or it may not terminate. Otherwise, my obfuscated code, that is P dash, it must terminate and it produced exactly the same output as original P. So P is my original program, P dash is my obfuscated program. Whatever is the output of my original code, my obfuscated code should resemble that exactly. But my obfuscated code should be in such a way written that no another person is able to understand that for which particular reason it is written. So we have to play around with the logic of the code, and we have to change it in such a way that it should be difficult for an attacker to impose all sort of attacks, even though it comes to the person in the middle attack, or even if it comes to ransom attack. So all those code attacks won't be possible when you have a mechanism as source code obfuscation. Now, this era is basically widely used, and this obfuscation approach is divided into code-oriented and data-oriented obfuscation. There are a lot of research which is already going and currently, which has already done and currently going into this mechanism of obfuscation, which is divided into code and the data. So data-oriented obfuscation is divided into graded encoding, whereas code will go to preventive, transformative, and polymorphic. Now, in preventive and polymorphic, you can just change the inner titles of your particular code to some other encrypted one. Well, that's not the enough one. So we have to actually target the transformation obfuscation, which is in the middle. And transformation obfuscation is also divided into layout, control, and data. So out of that, we will be concentrating on a data obfuscation, in which we will try to change the logic of the source code and try to get exact same code as the original one. So as I said, the gaps, that even though we have obfuscation by the control flow, even though by the transformative flow or by graded encoding mechanism, even though it is used widely in the practice, but whenever values are stored into program binary, because as I said, the program computer always understand binary language. So there are possibilities that your code may be attacked. And then in that case, the detecting that flow of the control would be very, very difficult. So in order to protect against all sort of malicious reverse engineering attacks in all the sites, we have to apply data obfuscation mechanism. So we will be taking some of the C programs, and I will show you that how exactly in C programming language you can apply the obfuscation. Now, please observe the original code which I have written in the Java in this case, and its equivalent obfuscated version. If you have observed, the function foo is used with one argument. There is some string which would be used with some variable. The name of that variable is my variable one. There is a second variable whose value is 24, and we are just trying to go for variables are. First variable is my variable, and second variable is that integer variable. So some string and 243600 should be displayed. That's what the logic of this particular code. Now, when it is obfuscated by the traditional means, you can see here, since the name of function is predefined, you cannot change that. So name of function is as it is. Name foo, as it is user defined, you can see that it is encrypted now. Argument 1 is encrypted. Variable is var, it cannot be changed, it is as it is. Second var is as it is. Document dot write is the functionality which we can apply. So document write would be as it is, remaining all things are getting changed here. So we can call this as one of the obfuscated code, and either by looking at least we cannot see that. we cannot, observe that, okay, this is something, the code is obfuscated, and attacker may find it difficult to understand, but there are mechanisms to deobfuscate it as well. Now, when I have clicked onto the link, you can see that these are the source formatex website, in which this is the original code before obfuscation. Now, after obfuscation, the code is written one line after another line. So you can see that this is also probably one of the way of obfuscating. Now, the same example, I have also added it into the slide so that you can understand. In original code, you could see that what's happening around and you can trace the logic. But in the obfuscated code, as all the lines are written one after another, now it would be little difficult, not be exactly difficult, but little difficult for the attacker to understand what the particular code is written. But by providing some bit of, efforts inside, attacker is able to get that. Now, what is it? This is the winning entry from International Obfuscated C Code Contest. Now, you could see here, whatever the code which is written here, no one is able to understand for what particular purpose it is written. You could see stdio.h, main, character, these are the things which you cannot change. So these things would be as it is, and rest remaining everything is changed. And if you see, if you can observe, lot many hash symbols or lot many and symbols and things are operative here. So this is one way of doing the obfuscation, in which by observing the code, it would be very, very difficult for the attacker. Now, the literature talks about variety of obfuscator evaluation. So you may be thinking of, do we have any sort of mechanisms or ready-made tools? Because nowadays we are reluctant on, heavily dependent on the obfuscators. So these are all the obfuscators which are currently available in the market, like Stunix obfuscator, Picheta obfuscator, Tigris, Mangalet, Semantic, P-lock, or CodeMorph. Now, these are the languages which are supported by this obfuscator, like Stunix supports C, C++, Java, or Perl. Picheta supports C, C++. These tools are available on online version, like Picheta is available on online version. It is supported. Almost all the tools are supported by your Windows and your Linux operating system. And in input, you have to give the source code. Once you click the button, it will give you the executive, it will give you the obfuscated code. So these are all the obfuscators which are available in the literature. Now, I'll show you the execution of Picheta. I have clicked onto this link. You can observe that this particular window have written just the code that hash include stdio.h and printf is hello world. When you normally compile it, it will give you the hello world which is displayed onto a screen. Now, when I obfuscate it in the sense, see, I have clicked onto obfuscation. Now you can observe the output. See, stdio main is as it is, and in printf, hello world is changed to something this. So now you cannot predict that hello world is written here. So it has changed. Now in this way, your obfuscator of Picheta gets work. Now, when I just click onto it, and I'm so sorry, I have changed the semicolon. For example, I have declared my variable integer a comma b. Now, how this variable a and b would be changed? The moment I obfuscate them, you could see that the value of a is now changed to this much of hash value and b is changed to this much of hash value. So we cannot, predict here that variable a and variable b is declared. And if you run this particular code, then whether it will work, whether it will give you hello world, no, then there is no use. So we have to go for a mechanism in which my code should be protected also, but at the same time, it is executable also. So these are the mechanisms which are available in the literature, wherein almost all the obfuscators are work on the layout obfuscation, that the layout of the code is being changed. But it also changes the inner working, and now your compiler don't understand that integer a has converted to this hash value and integer b has converted to this hash value. It won't be, understand by the compiler. So if it is not understood by the compiler cannot execute that. Then there is no mechanism in, saving or in protecting that particular code. So obfuscation methodology in top of that works on a different way, not on all the data obfuscation. Similarly, the working of Stunix also. If you click onto the Stunix and if you provide any software C code, it will give you the obfuscated version, but that obfuscated code is the layout obfuscated code and it will not run, it will not executable. So what we have to do? We have to have some of the mechanisms like reference pointer obfuscation, shift operator obfuscation, XOR obfuscation, XOR shift operation obfuscation, in which I'll show you one by one that how these mechanisms are working. So sometimes we also have a dead code, that code which does not perform any functions and the code which does not have any effect in the code. Even if we remove that, then it will not make any difference in the rest of the program. So if you particularly calculate the function and later on you try to add, so it is just the calculated, but it is not used, it is not saved somewhere. So it can be usually removed because, by the compiler during the compilation process, as the part of optimization, compiler understands that this particular code has no effect and it can be removed. Similarly, there is an unreachable code. Unreachable code in the sense that, for example, I have a function, I have returned X, and after returning X, now I'm performing A plus B. So since the value is already written, after that, even though I do any computation, it is unreachable. So these sorts of codes are also removed by the compiler during the compilation process. So unreachable code and the dead code are also two mechanisms in which you can add a lot of dead code inside your particular code, so as to, move attention of your attacker from one piece to another piece. So it may get confused with such sort of dead code or the unreachable code which is added inside. But since we developers are smart, the attackers are more smarter than us. And this is the even though I made a very strong statement, but it is proved that attackers still are able to attack into a code and they try to, get that intellectual property. So with all these mechanisms which I have shown to you, which are available in the literature and not able to protect your code, then what are the mechanisms which we can apply? So let us start with some of these mechanisms, in which I would like to explain the first mechanism as a reference pointer obfuscation mechanism. Before I explain this particular mechanism to you, please observe this code, that this is the experimental evaluation. Now look at my original code. My original code is, I have three variables as integer a comma b comma c. I will accept that two variables from the user as a and b. I will add them and store the resultant in C. And I will display the addition. Now, how I can obfuscate this particular code? This is my original one. Now, I need to obfuscate this particular code in such a way that my obfuscated code should be able to execute. So, which mechanism I'm applying? I'm applying the mechanism of reference pointer mechanism here. Now, what is reference pointer? As we all know, that pointer is the variable which always holds address of the other variable. Like, for example, I have a statement as integer pointer p, a comma 10. So variable a assigns to the pointer and you can write p is equal to end of a. So when this assignment is made to the pointer variable p, then that p is allowed to hold memory address for that variable a. So whenever we are referring p, it will always give you address of the a because it is the reference pointer. On the other hand, we can use dereferencing pointer. Dereferencing pointer. Like instead of using and will give me one address. If I use two and, so two ands is known to be as a dereferencing pointer. So dereferencing pointer will return me value, not the address. So it means I'm using a mechanism on top of the pointer. Like I'm using the mechanism of a dereferencing pointer, which will return the value which is stored in the variable a, not its address. So that's the difference of and of a and of a. So this is what exactly is being implemented here. So if you could observe in the main function, now I have two variables as a and b. I will accept their values from the user as a and b, and I will print the resultant. In printing the resultant, I will call the function because in the main I'm calling the function here. So function of a comma b. Now it will go to this. This is my function declaration and my function definition. Now what is written here? Integer function with two formal parameters x comma y. These are the two formal parameters to my function. Now what I'm writing inside? I'm declaring the character pointer k and I'm assigning it to 0. Because since I'm storing the sum of two variables, my reference pointer or the pointer at which I'm going to store the particular resultant should be equal to 0 as well. So I'm assigning it to 0. Now, please observe this line. What I'm returning? I am returning a dereferencing pointer of it. So return and in bracket and of k of x and k of y. Now in this case, x is my first formal parameter, actual argument is a, which I have accepted from the user. For example, I have accepted value as 4. So since I have written and k of x, in this case, it will not give you address, it will give you value of that x. X is the value of actual argument, that is a, which was 4. So 4 is given here. Apart from that, this 4 is now appended to y. So what is y? Y is my next formal parameter. Actual value is b, which I will accept from the user. For example, it is 4. So 4 appended to 4. In total, what it will return? It will return 8. So 8 is what? 8 is the addition of 4 plus 4. So instead of writing directly as C is equal to A plus B, I am trying to obfuscate it and try to write it in such a way that it will still return me answer as 8. So this is one way of doing it. Like I'm trying to camouflage, I'm trying to, make my attacker into difficult position, that by looking into this, it would be difficult for him, for the attacker to understand for which particular reason this code is written. Now I'll show you the execution of it. I will go to my compiler. You can observe here that same code in the programmer's editor I have pasted. And here I have accepted two numbers from the user as 4 and 4. And you could see here the addition of both the numbers is 8. So this is how the obfuscation must work. This is how the obfuscation must work. So this is the first mechanism of, reference pointer obfuscation mechanism, and in which we can use the concept of dereferencing pointer, not the only pointer. So this is the one way of doing it. Second one, now what all mechanisms which we can apply in such a way that my code is obfuscated, it is protected, but at the same time it is executable. So let us please observe the second mechanism of it, which is known as XOR or var merge obfuscation mechanism. Now, XOR is the operation and var merge is the other methodology. And we have actually used the combination of both the methods. So what are these two methods? XOR masking is actually obfuscating the clear value of the variable. So if for example, the variable A and the value of that variable is 10. So we are trying to encode the clear value of the variable by using bitwise XOR operation. And in order to do so, I have to use some mask. So I have used one integer constant mask with some value so that I can encode the original value of the particular variable. So since for addition of two numbers, I need two XOR operations to be done, which is always denoted by masking. So I will take one mask, and with the help of that mask, I can encode the value of first variable, I can encode the value of second variable. That is XOR. Second one, var merge. Now, basically, var merge is the biggest approach. For example, I have variables as v1 to vn. So domain of all these variables would be represented by their b of v1. Var merge is creating another variable as, let's say, m, and the original variables you can map to the operation of all this merging variable by a masking operation and shift operation. So what is this var merge I have used? I'll show you the code as well. So if you combine XOR and var merge together, these two codes, I'll show you that resulting code would be very, very difficult for an attacker to guess the original logic. Please observe this code now. Now, what is my original code? My original code is accepting the two numbers, add them, and then display the result. It means if I accept two numbers as 4 and 4, the output should be 8. Now, how I can obfuscate this particular code? Now, please observe this one. Here, I have actually declared unsigned long. Now, why it is unsigned? Because I need to work more on 2 raised to 16. I am using the concept of var merge. So I have to declare my variables with unsigned data type. I have used masking operation as 0x20. It will mask all the bits. Remaining bits would be kept as it is. Accept two numbers from the user, like A and B. This is normal. As I said, with XOR mask, I will mask it. But here I will not give any clue to attacker that which mask I have used. I'm using M. What is M? So I'm actually using M is equal to 12. And I'm creating AE, that is XOR mask of first number, BE, that is XOR mask of second number. Now I'm using this AE and BE. These are the two numbers I'll be using, and I'm using OR operation with AE and BE, and I will shift them with S. S is what? 0x20. So this is the right shift operator. So whatever is the OR operation of my mask of two numbers, I will right shift them with S, which is 0x20, that is hexadecimal value. Now, this is the hexadecimal value which is printed in X. So if you can, add it with 0xFF, because this is the hexadecimal operation which can convert all the remaining bits to 0. So these bits are 0. It means all your operations are actually stored into the left-hand side. So in that left-hand side, you will get original value of variable A plus original value of original B, and you try to return that particular result as addition of two numbers, 4 plus 4, which is equal to 8. So if you observe the original code and if you observe the obfuscated version of it, I'm sure that it is very, very difficult for you all also to understand that how exactly it is written. I will show you the execution of it, which I have done. So I'll go to Programmers Editor again, and let me show you that how this code is tried to execute. See here, that same code I have kept into a Programmers Online editor. And if you run it, it will ask you to enter two numbers. Like for example, 3 and 5 I have entered, and you can observe here that addition 8 would come. Code is executed successfully. So in the printf option, you have added 3 plus 5, and then you can get the output as 8. So instead of writing C is equal to A plus B, you can write it in this way. And this is the one of the obfuscation mechanism you can apply so that your particular attacker would actually put down himself in a very difficult position, because he is not able to understand what all this is written for. Now I have this third mechanism, that is shift operation obfuscation mechanism. In this particular obfuscation mechanism, the concept of bitwise shift operators are used. So these are the most common procedures which are actually used in the process of source code obfuscation, because many of the mechanisms which are developed by us and which are developed by the other researchers or a scientist, they also have used shift operation obfuscation mechanism widely. That's what I have mentioned, that these are the most common procedures which can be used in the process of source code obfuscation. But very few obfuscation mechanisms uses the concept of recursion, which we have used. So shift operation along with recursion, we have used, and we have made the code very difficult to understand. So which bitwise operations I have used? I have used bitwise AND, left shift operator, and XOR operator, so that I can perform addition on this plus operator. So please observe the code now. See, original code is addition of two numbers, and now I have written it into this way. I'll explain you that which particular way it is written. So I have declared the function here. A semicolon is given with two formal parameters whose data type is integer. I'll go to main, in which I'll declare two variables, accept the value of two variables from that. I need to display the sum of these two variables, so I will call a function which is being defined here. This is declared, here it is called, now here it is defined. Now what I have written in the defined function, I have not written normally C equal to A plus B. So which bitwise shift operations with recursion I have done? See, if first number is equal to 0, it will return number 2, because if I wanted to add number 0 and 3, addition is always 3. If I wanted to return addition of 3 and 0, addition is again 3. So if first number is 0, return second number. If second number is 0, return first number. Else, look at the mechanism which is being implemented. Return. Call this function again. That's what I said, that do it in the recursive way. So here I'm calling this function again. Like function within a function is the concept of recursion. So I'm calling this function here again, and I'm doing logical AND of my first number and second number. I'm writing it shift by 1, and then comma, I am using number 1 XOR number 2. So these operations would go in the recursive fashion unless and until either of the number becomes 0. And hence I have given this condition as, if the number 1 becomes 0, return your second number. Otherwise, if second number becomes 0 by this procedure, you can return number 1. Else, do this particular process in the recursive order in such a way, call this particular function recursively in the such a way that ultimately it will give you addition of two numbers as 8, if two numbers are 4 and 4. So if you observe this code, here it is easier to understand, but what is written here? You have to actually do the lot of calculation. You have to take number 1 binary form and number 2 binary form, because in number 1 AND operator, if you logically use, you have to convert both the numbers to logical AND operation. Then you have to right shift to 1, and then you have to go to XOR of particular operation. So this is the third mechanism which is being implemented. I will show you the execution of it. So it is being implemented with the program is editor. Please observe that in this case, this particular logic is written, and here the same particular function, that is this particular function is called in the recursive way. And if I run, it will ask me to enter two numbers 4 and 4, and still the addition of two numbers is 8. So in this way, the code which is very difficult to understand, but still it is able to give you the output that which is equal to 8. So this is one of the strongest obfuscation mechanism, we could say. And we also have extended the operations of XOR shift operation mechanisms in other way. Like how can I use it into a do while loop or the other loops? So we have developed the fourth mechanism, which is known to be as XOR shift operation mechanism. So in this mechanism, we are using bitwise AND again, left shift operator and XOR operator, which can perform obfuscation for addition of two numbers. But this code we have done with the help of while loop, that is while code structure. So to show the working pattern, we have actually used three integer variables, A, B, and C. A and B would take the numbers, these are the two numbers, and C is actually being stored the resultant. So unless and until your while loop is alive and your second number becomes B, it will return the value of that 0. Unless and until it is 0, you can return number 1. So shift operation mechanism are implemented again in the recursive mode, whereas this particular shift is using with the help of while. Matlab in earlier example, we have used concept of recursion. Here, we have not used concept of recursion. We have used concept of while loop, but still we are able to obfuscate our code. So please observe what's happening. In the original code, as I said, addition of two numbers. If you obfuscate, still it is addition of two numbers. But please observe that how it is written and how it is difficult to understand. So integer A, B, C, accept two numbers from the user. Look at this. Unless and until your second number is not equal to 0. C, that is the resultant variable, should be A and B. So A ka binary, logical AND it with B ka binary. Then A is getting changed with A XOR operation of B, which been used with the C now. And B is equal to C, which is logically shift 1. So ultimately, if you perform all of this operation, resultant would be stored in the A. And that A is able to give you that addition of two numbers, because ultimately B becomes 0 here when you perform these heavy operations of logical shift and the XOR operations. Logical AND, logical OR, and then the shift. If you perform that recursively, B becomes 0. And ultimately, the resultant is stored in the A, which is actually addition of two numbers. So I'll go to program is editor again, and I'll show you that, see, the same code which I have just now explained to you, if you just try to execute, it will accept two numbers from you, 4, 4, and it will generate your resultant, which is equal to 8. So this is how there are a couple of obfuscation mechanisms, which we can implement, we can thought of, and we can always think about all these way, which we can add inside the code such that our code is still able to execute, but it would be very, very difficult to trace that what logic is written inside the code. So that's how the obfuscation mechanism and the objective of obfuscation mechanism built upon. So we have to heavily look into the particular code, and we have to look at how all we are going to convert it, because encryption is the converting mechanism. Similarly, obfuscation is also a converting mechanism. So how nicely you can convert your original code to obfuscated code in such a way that number one, it should execute as it is. Number two, that it is very difficult for the attacker to understand. So with this note now, I come to the conclusion part of my entire presentation. If you observe the screen, you would realize that your computer, your laptop is actually having a lot of data. And that data or that information or that source codes are of a lot of importance. And if the attacker is able to steal that, he may earn and he may use it for all the malicious purposes. So this diagram suggests it all. So before your data, your source codes are being attacked, please try to provide the provision mechanisms so that you would be able to protect not only your information, but the source codes as well. So to keep the possibility of insider attacks in the cloud as well, to protect your source code from stealth, you can apply the obfuscation mechanisms. So obfuscating the entire code may not be possible. It may be cumbersome, because you could see that my original code was having only 3 lines. My obfuscated code is having 5 lines. So it is memory overhead also. It is execution time overhead also. But even though you have overhead, but this is the price actually which we have to apply in order to protect our code. So we can apply a variety of data obfuscation mechanisms. These data obfuscation mechanisms can work upon the arithmetic operators like add, subtract, multiply, divide, mod. So on these all operators, not only on plus, I have currently shown to you the obfuscation mechanisms on plus, but there are a couple of other techniques which we have developed in order to protect all our other operators. So these are all the essential part of source codes, because source code is not about only plus operator, it is about everything. So we actually have, we can implement the novel technique, and we can just go for securing the software. So in COVID-19 situations or a scenario, since then, we actually, our responsibility increases, because we have to go for implementing all the novel techniques. Now, novel in the sense that it should not be implemented earlier. And secondly, it should be very difficult for the attacker. So together we all can proceed and we all can go for securing our software. So with this note now, thank you so much for patiently listening me. And if you have any questions, you can post these questions onto a chat box. Yeah, please post your questions on a chat box. And with this note now, we will stop it here. Sharan?
Thank you so much, Pallavi ma'am, for such a wonderful session and interesting session to all the students and faculty members of PCU.
Yeah, thank you, ma'am. Thank you very much.
Thank you, ma'am.
Yeah, thank you, Sharan. Shall we leave?
Yes, ma'am. If there's no questions, then we can leave, ma'am.
Yeah, there is
Ma'am, we have, I think, one question in your chat box.
Yeah, I do answer that. So the question is, ma'am, what if we do listening to our source code? Yeah, it's a very correct question, and it is asked from Aditya Kumar. So I would like to answer you, Aditya, that listening of the software would just give you a proprietary informations or proprietary things to you. So listening means you are the owner of it, but it does not mean that you can protect your software. In order to protect your software, because when it comes to attackers, they are just looking at what is the logic of this particular code, and they do understand that if it is addition of 2 numbers, my attacker is able to change it to subtraction of 2 numbers. So when you try to deliver it to your client, instead of addition, now at client's end, the subtraction code is working. So you have to apply the mechanisms in such a way that you can protect your software. Licensing of the source code will only give you proprietary rights, not on protection rights. Aditya, thank you so much for the question. Any other thing? Any other questions? Okay, so I hope since there are no questions now, Sharan ma'am and Dr. Neeru ma'am, I think we can stop it here. Thank you so much. All the
Ma'am, there is a question, ma'am. What is token mechanism, ma'am? From Maitri Agarwal.
Maitri Agrawal. Okay.
Yeah.
So I could not see that actually. So Maitri, as I shown to you one particular diagram. So token mechanism, I will again show you if madam will allow me 2 more minutes. So see, tokenization of the software in which I have shown you actually this diagram, and it is heavily being used with the credit card systems as well. If you can see here, so these are the payment options of the credit card mechanism. So these are all the one token per one wallet. So you can just generate one token out of it, and this will substitute the specific value. That value could be meaningless, but then your authorized user may link that token back to the original data, and that one token goes off. So second time when you try to use, you have to use the second token mechanism again. So such sort of mechanisms would work when we have what would I say, transaction mechanisms or a banking mechanisms. Then in that case, tokenization can be used. But when it comes to softwares, well, we cannot just apply only one token to the software, because even though that value is meaningless, the attacker is still able to understand, attacker is still able to understand that this is the token which is written, and he would be able to get that. And though the tokens are also valid for only one time use only. So this we cannot use for the securing the software. Yes, Aditya, there is a question that can you please share the PPT to us? Yeah, since it is already published, so things would definitely be shown. Now, there is another question that we discuss about how obfuscation of source code can be done. But when we talk about software, which is in the bigger scale, so what are the additional steps while taking or securing the software? Yeah, Shivang, thank you so much for the question, Shivang. The answer to it is source code obfuscation, you can apply it in the part of the code or even in the whole of the code as well. When you have a mechanism, enough for a strong mechanism, because these are the only 4 mechanisms which I have currently shown. Apart from that, there are many mechanisms. Even I myself have developed 12 mechanisms to protect my software. So if you have such strong mechanisms which are there with you, you can apply it to whole of the software as well. Or for the IP, you can just apply for small piece of that obfuscated code. For remaining all, you can encrypt it with the layered mechanism as well. That can also show you the entire piece of the software is being protected. There are basically mechanisms, Shivang. One is the flaw finder mechanism. Other one is the clockwork. There are many tools which are available onto a cloud, which can detect such sort of code queries as and when the developer is going to type that. And code flaw finders or a clockwork mechanisms, which is heavily used by industry nowadays, they can detect such flaws. So you have to provide them the original code. You cannot provide them the code which is being already encrypted. So in this case, part of the software you can use, or well, you can also go for providing the layered mechanism to the other part of software as well. Anyhow, you have protected the logical part of the code, which is intellectual property of the code. So that's what the question is. Ma'am, yeah, there is one more question, that what is encryption layer in the code or software? Correct. So I have shown to you some of the mechanisms. There are basically lot many algorithms which are available, like RSA algorithm, SH algorithm, or MD5 algorithm. So these forms of encryption mechanism can convert whatever you write. Like I have shown you integer of a comma b. If you remember, here I have shown you in my first slide itself. Okay, I think I have closed that. So I have shown you that when I can have integer of a comma b, a is converted to some big hash 24 bits of size. So these are the variety of algorithms which can be used for protecting the information. For protecting the software, one should not use that, because if you protect that, then there are still small possibilities that your software is able to execute. Because if the software is not able to execute, though it is encrypted, then there is no meaning. So you have to go for obfuscation mechanism in terms of software, Maitra, not the encryption layers. Yeah, I'm very happy with this all questions. Any another question? Yeah, Madam, Sharan, Madam.
Yes, ma'am.
Okay, I think there are no questions now. Then we can end up the meeting.
Yeah. Thank you so much, ma'am.
Thank you very much for patiently listening. Thank you so much, Aditya. Thank you very much, Aditya. Thank you.